Assalamualaikum and salam sejahtera. Today we are going to learn about subtopic 11.3, which is Introduction to Particle Physics. 11.3.1 is about thermionic emission, where it is defined as the emission of electrons into the vacuum from a heated conductor. So as you can see in the figure below, the electrons are emitted from a hot filament. So the thermionic emission is widely used in the particle accelerators and particle detectors. So the rate of thermionic emission can be increased by two ways. The first one is by increasing the temperature. The second one is to replace the filament with low ionization metal. 11.3.2 is about particle accelerator, where it is a machine for increasing the kinetic energies of charged particles such as electron, protons, used for research in nuclear and particle physics. There are two categories for particle accelerator. The first one is linear accelerator, and sometimes we call it as LINAC. It is a type of particle accelerator in which charged particles are accelerated in a straight line, either by a steady electric field or by means of radio frequency electric fields. The figure below shows a simple diagram of a LINAC. A beam of electrons are accelerated through each tube A, B, C, and D as the AC supply change its direction vertically and then head towards the target. This process must occur in an evacuated chamber. The second category of particle accelerator is circular accelerator or cyclotron. This is a type of particle accelerator in which charged particles are accelerated in a circular path by means of radio frequency, electric fields, and magnetic field. The LINAC we use to treat all parts and organs of the body, especially cancerous cells, while sparing the surrounding normal tissue with higher doses of radiation. The energetic particles produced in the cyclotron are used to bombard atomic nuclei and thereby produce reactions. These reactions can be used to produce radionuclides, which can be used by medicine, industry, or research. One of the most significant developments in modern physics is the emergence of the standard model of fundamental interactions. This model states that the material world is made up of two categories of particles, which are quarks and leptons, together with their antiparticle counterparts. Elementary particles can be divided into two particles, which are hadrons and leptons. Leptons consist of electron, muon, tau particle, and three types of neutrino. It is a fundamental particles with no structure or measurable size, and weak force acts on each particle. Each of the 6 particles has an antiparticle, and the neutrinos do not have electric charge. Meanwhile, electron, muon, and tau, all three have a charge of -1. The second type of elementary particles is hadrons. It is a complex particles that have size and substructure, and strong force acts on each of them. For your information, hadrons are set apart from leptons because they are composed of 2 or 3 fundamental constituents called quarks and separated into 2 categories, which are baryons and mesons. Mesons is a hadrons whose masses are less than the proton mass, which lies between the mass of an electron and the mass of a proton. Mesons are made of a quark and antiquark, and all are very unstable. The mesons particle such as pion or pi meson, kaon or k meson, and eta, which is uncharged particle. So now you can see the quark composition for each mesons particle in the table on the right side. Next is baryons, that hadrons that have masses equal to or greater than the proton mass. The baryons are composed of 3 quarks, all but 2 baryons are very unstable. They are the proton and the neutron. The examples of baryons particles are proton, neutron, lambda, sigma, and omega. As you can see, all of them are made up of 3 quarks. The last one is antiparticle. So you should know, for every particle, there is an antiparticle. So it is actually a subatomic particle that has the same mass as the particle, but opposite in charge and spin. Now, look at to this table. For quarks particle, which is up quark with charge positive 2/3 electron, it has an antiparticle which is anti-up quark with opposite charge negative 2/3 electron. And for the leptons, the particles such as electron with charge negative 1 electron has antiparticle called positron with opposite charge of positive 1 electron. So I think that's all for today, and thank you for your time.